So let's go back to 2-1, page 4 for a second, because I've gotten a lot of questions about this. So what I need you to remember is that voltages and currents can be labeled any direction, any polarity on a circuit. Why is this not on? Hold on. Voltages and currents can be labeled any direction and any polarity on a circuit because they represent a voltmeter reading or an ammeter reading. They don't necessarily tell you anything about the current flow or voltage drops. You have to stick with what I told you about the passive sign convention to solve for those things, okay? So if 18 equals 6Ix, Ix is 1/3 amps. Since the current flows clockwise, the voltage drop across the 2 ohm is actually the negative of V2. Voltage drop is current into the positive and out of the negative. So this would be the negative of -2Ix. So the voltage drop across the 2 ohm resistor is 2/3 volts. It is, thank you. Is that Taylor? Yeah. Thanks, Taylor. That's 3 amps, sorry. So then this would be 6 volts. But V2 is -2Ix, so V2 is -6 volts. I can have a voltmeter that reads -6 volts. That does not mean the resistor is delivering power. It just means I reverse the red and the black on the voltmeter. And V1 just so happens to be consistent with the voltage drop across the resistor. So that would be 4Ix. So V1 is 12 volts. And the voltage drop across the resistor is 12 volts. Okay, so the problems on the quiz that were messing everybody up. There was one like this that asked you to find the current I. Because current is actually being delivered from the 3-volt source, I is -3/4 amps. You tell me that I is 3. Okay, if I ask you to find a labeled value on a circuit, you have to put the plus or minus sign if it needs a plus or minus sign. That's different from if I'm asking you just to, in general, find voltage drops across resistors on a table. Okay, let's do one more and then we're moving on. So, if I ask you to find the voltage across this resistor, it's a labeled value, Alex. So this is 100 milliamps. And this is 1 kiloohm. Write this down if you missed it on the quiz, please. I know that resistors drop voltage. So this is not telling me that the resistor is delivering power. It's telling me that the red and black on my voltmeter are measuring the negative of the voltage drop across that resistor. So V is -0.1 times 1,000 or -100 volts. All right, you got to get this straight. Everything we do depends on this. This is the holy grail to everything we do. If the chicken in this sauce is rotten, nothing else is going to work that I'm going to teach you. You got to get this, children. Resistors only drop voltage. Resistors only absorb power. That's it. Can I use a light bulb to turn on my car? Remember, we model resistors with light bulbs. Light bulbs are a load. That's it. They don't generate power. Lecture 2-2, we're doing more Kirchhoff's voltage law and Kirchhoff's current law, and showing that even if the circuit has dependent sources, we can do the same analysis and show that it obeys the law of conservation of energy. The special thing that happens when we have a dependent source, though, is we get,